So this is a chemical equation, shows a chemical reaction. As we said, a chemical reaction, it involves formation of new products, okay? In any chemical equation, we have reactants and products. Reactants, the substances, the chemicals that react together to produce new products, like here, like silver sulfide and hydrogen gas. Now, before we start balancing, it's very important to understand the following, that a subscript shows number of atoms in an element or a molecule or even a compound. So the subscript, which is the number written here, like here, it's H2O. This too, it's a subscript. It shows number of hydrogen atoms in water molecule. It means that we have 2 hydrogen atoms in this water molecule. And since here we have no number, so it means we have 1 atom of oxygen. So this is the subscript. Again, it shows number of atoms in a molecule or a compound. So the ratio of hydrogen to oxygen, it's 2 to 1. It means each hydrogen atoms, they need 1 atom of oxygen. Now, coefficient is the number written in front of the atom, the element, molecule, or compound, okay? So the number written in front of it, it shows number of molecules. Like for example here, you have 3, H2O. It means we have 3 molecules of water, okay? Now, if I have a coefficient and I have a subscript like this here, and I want to find number of atoms, like for example, 3H2O. It means that we have 6 atoms of hydrogen. Why is that? Because we have to multiply here to find the number of atoms. Like 3H2O, it means 3 molecules of the whole water molecule, 3 molecules of water. But if I want to know how many atoms of hydrogen, just hydrogen, so here I have to multiply 3 times 2 is going to be 6 atoms of hydrogen. 3 times here nothing, so 1. 3 times 1, it means 3 atoms of water. We're going to practice this more. So subscript, number of atoms within the compound. Coefficient, it shows number of molecules or number of atoms, also if I have an element. Okay. Now, why do we do balancing? Why balancing is important? Now, you know that in physics, in chemistry, there is 2 important laws. The first law, which is law of conservation of mass. And also we have law of conservation of energy. Now, law of conservation of mass, conservation of mass. So it means that in a chemical reaction, matter is neither created or destroyed. Okay, it means that number of atoms in the reactant must equal number of atoms in the product. It means that in a chemical reaction, if 2 hydrogens of atom, 2 atoms of hydrogen found in the reactant, I must have also 2 atoms of hydrogen in the product. Same for oxygen. If I have 2 oxygens, I'm going to have also 2 oxygens in product because we can just lose the mass. Mass stays the same, mass is conserved. It's not only the mass, it's also the type of atom. In a chemical reaction, if I have hydrogen in reactant, so I must have hydrogen in product. If I have oxygen in reactants, I'm going to have oxygen in product. We're gonna never have a new element comes from nowhere in product. For example, it's impossible to have here carbon in product because I don't have carbon in reactant, okay? So again, law of conservation of mass states that matter is neither created nor destroyed. It means that number of atoms and type of atoms or reactants must be the same as product. In another way, it means you're not gonna have a new element in product if it's not found in reactant, okay? If this happens, if number of atoms is equal to number of in reactant equals number of atoms in product, it means that this equation is balanced. You're obeying law of conservation of mass. And this must be the case. Whenever you work with a chemical reaction, it must be balanced. There is part of chemistry, which is stoichemistry, which is concerned about calculations. You can't do calculations unless your chemical reaction is balanced. Any question till now? Do you have any question? Raise your hand if you have. Okay. Since you have no questions, so let's see how can we find number of moles, number of atoms in a chemical reaction. Now, first of all, if I want to know number of molecules, which we can say number of moles in a reaction, I'm going to do the following. Now, the number in front of the molecule, in front of the compound, again, we said it's coefficient. So if I want to know how many molecules or how many mole of hydrogen atoms, so I'm going to say here I have 2 and here 2. So I have, or for example, number, let's say, of molecules of reactants. I have 2 hydrogens molecule and 1 oxygen molecule. So I have 3 molecules in reactant, okay? And I have 2 molecules in water. Now we're going to do that more and more, inshallah, in the comment section, in the comment sessions. But how to do balancing, okay? First of all, I'm going to show you how to calculate number of atoms again. So look at this coefficient. I have 2 hydrogen molecules, but how many atoms of hydrogen? Not how many molecules, how many atoms of hydrogen? I have here a subscript 2. So 2 as a coefficient, 2 as a subscript. These 2 numbers are for hydrogen. So if I want to know how many atoms of hydrogen, and folks, I'm saying atom, how many atoms of hydrogen, I'm going to multiply these 2 numbers. So 2 times 2, it means we have 4 hydrogen atoms, okay? Now, how many hydrogen atoms in product? I have 2 here in front of the water molecule. Since it's in front of the water molecules, it means it's for the whole water molecule. So this 2, it's multiplied by the hydrogen and with the oxygen. So I want to find only number of atoms of hydrogen. So I'm going to multiply 2, the coefficient, times 2, the subscript which is next to hydrogen, 2 times 2. So again, I have 4 atoms of hydrogen. So I have 4 of hydrogen atoms in reactant, 4 hydrogen atoms in product. So okay, hydrogen atoms number is equal in the 2 sides. Now, how can I find number of oxygen atoms? Now, do I have a number in front of the oxygen? We don't have a number, which means that here the number is 1. So to find number of oxygen atoms, again, I'm talking about atoms. When we count for balancing, we count atoms. So I have 1 oxygen here as a coefficient, and next to it we have this coefficient here, sorry, subscript here, which is 2. So 1 times 2, it means we have 2 oxygen atoms. Now let's find number of oxygen atoms in product. In front of water molecule, I have a coefficient of 2, which means again, when you find or when you calculate number of atoms, you're going to multiply this number with each element inside the compound. So we did already 2 times 2 for hydrogen. Now for oxygen, 2 times, there is no number here. So 2 times 1, okay? 2 times 1, which is 2 oxygen atoms. Now, number of oxygen atoms in products. and reactant is equal. So this reaction is balanced reaction. Okay? So this chemical equation is balanced. Do you have any question? If you have any question, raise your hand now. So you get the idea of coefficients and subscripts and how to calculate number of atoms. Is it clear? Sure? Okay. So whenever I'm doing balancing, there are specific rules that we have to follow. The first rule and the most important rule that subscripts cannot be added, removed, or changed. What does it mean? It means here you have H2O. You can just change this 2 into 1, for example, or into 3, just to make number of atoms equal. Because by changing subscripts, you're actually changing the whole molecule. Because H2O, it's not the same as HO or H2O2. H2O, it's water, while H2O2, it's hydrogen peroxide, totally different compounds. So, in balancing, subscripts cannot be added, removed, or changed. So, how to do, again, balancing? To do balancing, I can only change coefficients. I can only change number in front of the element, in front of the compound, okay? Only this number, the coefficient. Subscript stays the same, okay? Third rule, coefficients can only go in front of the chemical formula, in front of a chemical formula, never in the middle of the formula. What does it mean? It means that, for example, again, in this reaction, I can't just go and write H2O because I want to balance it. The coefficient only goes in front of, okay? Few tips when you do balancing. First of all, when you have a chemical equation, try to balance big formulas first, okay? Save 3 elements for last. We're going to apply this now. You're going to see what does it mean. If you have a polyatomic ion, and this polyatomic ion is the same, it's not changed in the two sides of the equation, so keep it till the end, or you can try with it or work with it as one unit. What does it mean? It means that, for example, if I have sodium nitrate in O3, and in the product, I also have nitrate. It's not changed. So this nitrate, I'm going to work with it as one unit. Again, we're going to do this. There is no particular way to balance equations. Some equations are harder to balance than others. So there is no particular way, exact way how to balance. It depends on you, okay? The way you prefer to work with, which atoms you're gonna start with, okay? But the most important rule that the coefficient must be in the simplest form. Yani you have to go by choosing smallest numbers, not the biggest numbers, okay? Yeah. Now we're going to start balancing, and we will start trying what we just said, the rules, the tips, and everything. Before we start, do you have a question? Okay, if anyone likes to start with balancing? You already took balancing, so anyone who likes to start, just try it. Like, who's going to count atoms with me? I'm going to choose one of you to count number of atoms with me. Shall I choose, or are you going to raise your hand? Who's going to count number of atoms in this reaction? How many nitrogen atom do I have in reactants? Yes, يا نبيه.
Hi, Miss.
يا أهلا يا مس.
Okay, Miss. Nitrogen. We have 2 atoms.
Bravo. Excellent. Thank you,
Hydrogen. Okay.
Now continue.
Hydrogen, we have 2 atoms also in the reactant.
Bravo. Excellent. So in products.
In the products, we have one nitrogen. And 3 hydrogen.
Amazing. Thank you, Nabi.
Okay.
So one way to start balancing, maybe you're going to prefer it in the beginning, which is to count number of reactants in a number of atoms in reactants and products. You can do this table. It just makes it easier for you as a start. So I'm going to see how many nitrogen atom and how many hydrogen atom in reactants and products. So as Nabi said, in reactant we have 2 reactant and 2 hydrogen atoms. In products we have 1 nitrogen atom and 3 hydrogen atoms. So by looking at the table, number of atoms is not the same for nitrogen or hydrogen. Now, can I just change it? Can I just write here in the formula here, can I just write into H2 because I want it to be balanced? Well, I don't want to just waste my time, so I just want to solve it very quickly. So I'm going just to write into H2. Can I do that? Can I change the whole formula? It's easier. Can I do it? What do you think? Yes, Sarah Al-Asmar.
No, because you can't change the subscript, only you can add coefficients.
Bravo. Why I can't do that?
Because you will change the whole formula.
Bravo. I'm going to change the whole formula, which means it's totally different compound in products, which is not right. Okay. So what shall I do? Sarah said I can only change coefficients. Right. Let's look at nitrogen. I have 2 in reactants, 1 in products. So how can I make this 1 nitrogen 2? What can I do? The rule says, yes, Celine, you like to participate? Yes.
We will put a 2 in front of the N in the product.
So you want to write here 2. Okay,
Yes.
Bravo. Bravo. Okay. Now, after I did a step, whenever I do after each step, whenever you multiply or change coefficient, directly count number of atoms again. So I did here a change. So here I have to go count number of nitrogen. Now number of nitrogen, 2 times here there is no number. So 1 times 1, so it's 2. For hydrogen, I have here a coefficient of 2 and I have a subscript of 3. So 2 times 3, it means now we have 6 hydrogen. Okay, now nitrogen is balanced, but hydrogen is not. What to do? You can tell me what to do. Yalla. Who like to participate? Okay, yalla ya. Hala. Hala Ramadna. Yes, go ahead.
The coefficient which is in front of the hydrogen in the reactants would be 3.
Again, if you please, and raise your voice.
The coefficient which is in front of the hydrogen in the reactants would be 3.
Bravo. Excellent. Good. So, to make this 2, to change it into 6, I can just change the subscript. Again, we can only use the coefficient. We can only multiply. So 3 times 2, so it's going to be 6 atoms of hydrogen. Now, let's check if the reaction is balanced or not. 2 nitrogen atom in reactant, so it's balanced, and also in product, and 6 hydrogen atoms in reactant and in product. So the whole reaction now is balanced. And law of conservation of the mass is obeyed, okay? Right, let's do another one. Yeah, who likes to start? So first I'm going to put my table here where I'm going to see all the atoms that I have, all type of atoms. We have potassium, we have chlorine, and we have oxygen. Yeah, who likes to start by counting number of atoms? Who's going to count number of atoms? Okay, someone else, not Selena and Nabi. Yalla. Just count number of atoms. It's too easy and I'm going to help you. What about Bashar? Let's do it together, ya Bashar. What do you think?
Yeah, okay.
Yeah.
Yeah, okay. K, it's one atom.
Bravo.
C, one atom. And
Bravo.
L, one atom. لا ولا yeah, هاي L. One atom. And O,
Cl,
two
it's
atoms.
chlorine
Yeah,
together.
yeah, chlorine. And O, it's two atoms.
Yeah, it's 3.
How?
Look carefully. AClO3.
Yeah, but the other one, they said O2. Then they
Yeah,
added
you're
it.
counting products.
Yes.
It's okay. So we started by counting reactants. Thank you, Bashar. It's
Yeah.
right, perfect. So we start by counting reactants and then products, or you can do the opposite. It's the same, yani at the end, you're going to have the same number. So in products, I have 1 potassium, 1 chlorine, 2 oxygens. So, yalla, what to do? Potassium is balanced, yes. Chlorine is balanced, but oxygen is not. So, yes, Rama.
Okay, so we're gonna put for the coefficient for the oxygen.
Okay, so you want to start with oxygen. Bravo.
So I'll put 3 to make it so we can make the 3 at 6.
Bravo. And you will do the opposite on the other side, yeah?
Yes.
Bravo. Now, look at the numbers that we have. Bravo, ya Rama. Thank you. So look at the numbers, 2 and 3. There is no way to make 2 and 3 equal numbers. Unless I did like cross multiplication. I did the opposite. I multiplied 2 by 3 and 3 by 2 to find the common factor between them, which is 6. So this is what I'm going to do. Whenever you have like this, totally different numbers, there's no way to make them equal. It's not like a factor, but multiplied factor. So just switch them, like multiply the 3 by 2 and the 2 by 3. So here in products, I have 2 oxygen, so I'm going to multiply it by 3. And reactants, I have 3 oxygen, so I'm going to multiply it by 2. But why I wrote this 2 in front of the whole compound? I only want to change oxygen. Because again, one of the rules says that coefficient goes only in front of compound. I can't just put the coefficient in the middle. So I can't just say KCl2O3. I can't change that. I can't do that. I can't divide the formula into 2 parts. It's one compound. It's one thing, one unit. So the coefficient goes in front of it. Okay. Now we did a change. Let's count the new number of atoms. Now potassium is 2, chlorine is 2, and oxygen changed to 6. Bravo. Okay, good. But now it's not balanced again. Now potassium and chlorine are not balanced. So what do we do? Yes, yeah. Yes, yes, Celine.
We will put 2 in front of the potassium and chlorine.
Bravo. So we're going to multiply potassium chloride by 2. So now we count again, 2 potassium, 2 chloride, so perfect, it's balanced. Do you have any questions till now? No questions? Okay, let's proceed. Now here we have another reaction. Maybe it's a little bit complicated than the previous one. Now I'm going to do balancing in a different way. I'm not going to use a table, okay? Again, it's up to you, whether you can just write number of atoms, do a table, or just do it mentally. You even can do balancing without writing anything. Just do it mentally, write the final coefficient. Okay. Again, whenever I do balancing, start by counting. So let's count number of atoms. I have 2 carbons, 6 hydrogens, 2 oxygens, and reactants. On the other side, I have 1 carbon, 2 oxygens, 2 hydrogens, and again, I have another 1 oxygen. So if you notice here, we have a problem that oxygen is found in 2 products, not only in 1 product. So when I count number of oxygen, so it's actually 3 oxygen. Okay. Now, in this kind of reactions, since oxygen in products is found in 2 different compounds, so my advice, keep it till the end. Work with an easier one, okay? When you have this, keep it till the end. So I'm going to keep oxygen till the end. I'm going to balance hydrogen and carbon before and keep oxygen till the end because oxygen in product is divided between 2 different products. So let's start by carbon and hydrogen, up to you. Let's start by hydrogen. I think it's easier. So easy numbers here, 2, 6, so we can just work with hydrogen. Okay, what can I do? Yellow. Remember, you cannot divide, you cannot add, you can only multiply. So yes, Nabi. Any ideas what to do here? Okay, I'm trying to unmute you, but I can't. So I'm going to...
Yes, teacher.
Yeah, okay, go ahead.
What should I do again?
Okay, I want you to balance hydrogen. Let's start by balancing hydrogen.
Okay. Here we have 6 hydrogen, and in the product, in the reactants, we have 6 hydrogen, and in the product, we have 2 hydrogen.
Okay.
So we put 3 as a coefficient.
Okay, so you want only to
In the
change
product.
hydrogen in reactant. You just want to multiply it by 3, so you're going to have 6 hydrogen.
Yes, 6 hydrogen.
Okay, you can do that. So I can just start by putting 3. I'm going to go with you. So I can just put 3 in front of the hydrogen, okay?
Yes.
So I'm going to have 6 hydrogen atoms in reactant
And 3 oxygen.
to oxygen, 2 in CO2 and 3 in H2O. So it's going to be 5. Again, I'm going to have odd number. Now I hate odd numbers in balancing because usually they are like really hard to balance. So I have another idea, Nabi. My idea is to
Multiply them?
Yes, by 6, by
Multiply
even.
them.
Yes, thank you. By doing
So we
that,
can get 6 oxygen.
excellent. By doing that, I'm going to have also an even number for oxygen, which is I prefer to work with in balancing, okay? Now
We
again,
will get 8 oxygen.
bravo عليك. طيب, thank you, Nabi, excellent.
Welcome.
Okay, so now, after changing hydrogen here, H2O into 6, I get 12 hydrogen in product, so I have to change it in the reactants also into 12. Now again, why I did that, why I didn't just added 3 as Nabi said. Now you can start by doing that. You can start by number 3, but you will find yourself later multiplying again or changing again the 3 into 2. So let's do this way and see if it's going to be balanced. So 6 times 2 is 12 hydrogens in product and 12 hydrogen in reactant. Okay. Now, but after multiplying, number of carbon here changed. 2 times 2, it's 4. So now I have 4 carbons, not 2. So what I'm going to do is I'm going to change this carbon also into 4. So I will multiply it by 4. So now I have 4 carbon. Now what is left is oxygen. Let's calculate again number of oxygen in products. 4 times 2 equals 8. 6 times 1, it's 6 oxygen atoms. So the total of oxygen atoms in product, it's 14. So I want also in reactant to have 14 oxygen. Now it's easy to do. I already have 2, so I'm going to multiply it with 7. So it's going to be 14 oxygen in reactant and in product. See, this way it's much easier. If you started with the 3, you will find yourself later need another number, changing the numbers and also changing the coefficient. Like, how can I know which number to start with? Again, there is no specific way of balancing. You may start with any number you feel like it's right, and then keep changing the number, calculating number of atoms till you have the right number. And again, balancing, it's all about practicing. So with practice, you will have the right way in balancing, okay? Last question I'm going to do with you, which is this one. Fe plus O2, which is gives Fe2O. So iron plus oxygen, iron oxide. This is an oxidation reaction. Yalla ya Bashar. Yes, Bashar, go ahead.
Yeah, we have to change the first Fe, make it Fe2.
Okay, good, bravo. Okay, and then?
بس فكرت خطوة بس هاي اللي بعرفها الصراحة.
It's okay, bravo Bashar. Don't worry. Okay, so yalla, I have the easiest way. Again, think of the easiest way. 2 oxygen in reactants, 3 in products. Whenever I have 2 and 3, multiply them with opposite numbers, like do the opposite, multiply them. The 2 by 3 and the 3 by 2. So this is what I'm going to do. 3 times 2, 2 times 3. So the number now is going to be 6 oxygens in products, 6 oxygens in reactants. Now I'm done with oxygen. What is left is iron. Balance it. 2 times 2, 4 iron. So directly go to the last one, which is by itself iron multiplied by 4, and the reaction is balanced. See, it's easy. Balancing is easy. It's not hard. It just depends on practicing. Okay, like the last one, an easy one. I have here magnesium with oxygen. Here I have magnesium oxide. This one, it's an easy one. 1 magnesium, 2 oxygens, 1 in products. So what I'm going to do is to multiply this magnesium by 2 and the product magnesium oxide by 2. So now count number of atoms, 2 magnesiums, 2 oxygens in products, 2 magnesiums, 2 oxygens, in reactant, and 2 magnesium, 2 oxygens in product. Okay, this is our session for today. Do you have any questions? Any questions? Sure? Okay, our session ended for today. Thank you for listening.